In this video I will explain how important a X-pressure is to a locomotive, train, and how it works. What is a X-pressure? A X-pressure is a combination of compressor and a exhauster. Compressor part compresses the air, and stores it in a tank which is called reservoir tank, while the exhauster removes the air from lines and make a vacuum. What happens if X-pressor stopped working or malfunctioned? If you have a problem in compressor part and air is not compressed into main reservoir tank, the driver will not be able to move the locomotive, because the sensor in electronic control unit, ECU, will not give the authorization to the driver to transfer power from generator to motors, because engine needs air pressure to apply brakes. Normally a locomotive needs a air pressure around 5 to 10 in bars. If the exhauster part malfunctioned and the train coaches are running on vacuum brakes, then the coaches will not have brakes. I think now you have an idea about how important is a X-pressure to a locomotive. Most common X-pressors are equipped with 6 cylinders, 4 cylinders on exhauster part and 2 on compressor part. Each cylinder is equipped with 2 or 4 valves, and they are called intake valve and discharge valve. These valves are tensioned with a spring. In an intake valve, when the cylinder piston goes down and makes a vacuum, the valve spring will get compressed and opens the surface plate so the air fill inside the cylinder. When the piston moves up, then the air inside the cylinder will get compressed and will close the intake valve surface plate. Sometimes the both intake and discharge valves looks the same, but if you look closely you can see valve spring between the valve surface plate and the valve body. In an intake valve, the valve spring is placed after the surface plate, so the surface plate can compress the spring and opens up the valve, while in a discharge valve, the spring is placed before the surface plate. There are 3 main parts in the compression side, and they are low compression, cooling, high compression. Atmospheric air will be sucked to the low compression cylinder and get compressed, but due to heat generated by the compressor the air get heated, and as a result the air particles will be expanded. To reduce the expanding, air will be cooled from the cooler, which has a liquid or air-cooled radiator, and send into the high compression cylinder and get compressed again, and then sends into the main reservoir tank. In this high compression cylinder's discharge valve will be working as a non-return valve. Air pressure from the main tank will be directly on this valve. The next question is what happens when the air gets full on the main tank. That's when the CGS, the compressor governor switch, comes into play. A sensor will indicate the pressure on the main reservoir tank. When the tank is near its maximum capacity, a electrical signal will be sent to a magnet valve, which opens a air line from the main tank to CGS line. Let's see how it works. You can operate a inlet valve manually. If you press the top of this valve, the valve get open, and when you release it, then it get closed. When an inlet valve get fitted into the compressor, a spring will be placed on the top of the valve. A small piston will be placed on the top of the spring and a CGS cup will be fitted on top. The air line which get opened by the CGS magnet valve will be connected through here. When the magnet valve gets opened and air is supplied, piston inside the cup will press the spring and mechanically opens the inlet valve. When the inlet valve is open, the air will move through the inlet valve without getting compressed, which stops filling the reservoir tank.